NASA approves new Helio study missions. I'm Tonya Hall, and joining me is Dr. Nicky Fox, Heliophysics Division Director for the Science Mission Directorate at NASA. Welcome back, Nicky.
Hi, how are you?
I am good. Welcome back. Like I said, what are some of the current missions that fall under your purview today?
Well, so we've actually got some exciting news. We just selected 4 new missions to join our portfolio. We selected them in December, and so I'm excited to tell you about those. 2 of them are actually going to ride along with our IMAP mission. So IMAP is one of our strategic missions, and it's going to go out to the L1 point, which is at about 1 million miles away from the Earth towards the sun. And it's a very stable point. And actually that's where ACE and SOHO have been for a long time, providing that eyes on the sun and telling us what's coming towards us here at Earth. So IMAP is going to go and sit in that location or orbit in that location. And so they will have a suite that is looking at everything coming from the sun and the solar wind as it streams past IMAP. But as well as that, they're going to have a special suite of instruments that's going to look all the way to the very edge of our heliosphere. So the edge of where the sun's influence stops and we get into interstellar space. And they're going to kind of provide sort of remote sensing, imaging, and looking at how that fragile boundary between our sun and interstellar space, how that is changing all the time. And so it's a very unique mission. We're very excited about IMAP. It's going to launch in 2025. But along with IMAP, we're going to put an ESPA ring on, which is like an adapter ring that is going to take 4 other missions out to the L1 point. One of them was actually the Space Weather Follow-On, and that's a NOAA mission, and that's going to provide the real-time forecasting of what's in the solar wind. And then along with that, we also have Lunar Trailblazer. That's going to be obviously a lunar mission. And then our 2 Helio missions that are Glide and Solar Cruiser. And so Solar Cruiser is a technology demonstration mission. So it's a little bit different to what we normally do. It isn't a pure science mission. It's going to actually do a demonstration of a solar sail. And it's going to fly the largest solar sail. It's about 1,700 meters squared. It's a very, very big solar sail that will open, and that will start to open a whole new area or rather enable new science for us, because with solar sails, you can start to lift things out of the ecliptic so they can sort of start to get up towards where we want to go, which is really over the poles of the sun. Or you can also use them to get closer to the sun than this stable point. And obviously, the closer you get to the sun, the earlier you get forewarning of what's coming towards us here at Earth. And so that's a really exciting demonstration of this technology. And the other one is called Glide. And that is looking at the Earth's exosphere. And so that's really the very outer layer of the Earth's atmosphere. So the particles there are still bound, they're still gravitationally held to the Earth's atmosphere, but it's incredibly sparse plasma, not dense at all, mostly hydrogen and helium. And we've only ever had 4 images of the Earth's exosphere taken before from outside the Earth's atmosphere. And so this mission, for the very first time, is going to provide high resolution looks at what our very outer layer. So that's where Earth's atmosphere stops and space starts. And we're going to be able to look at how that atmosphere changes in response to things coming from the solar wind and things that are happening in our magnetosphere. So really excited about those 2 missions. And again, having them launch with IMAP is just providing us more science for less money, because we're only paying for one of the launch costs. So that's 2 of them. And then the other 2 missions that we just selected are EUVST, which is a bit of a mouthful, but it's a solar telescope. It's an extreme ultraviolet solar telescope. And that is a partnership between NASA and the Japanese space agency, JAXA, to do the next generation solar mission. And it's called Solar C. Solar A is now better known as Yoko. Solar B is better known now as Hinode, and this is Solar C. And so this is going to be the 3rd in that line. We're really super excited about this. It's going to provide totally new, unprecedented images and measurements of the solar atmosphere, where we're kind of fueling all of the space weather before it comes out and hits us here at Earth. And the last one is called EASY, and that is 3 CubeSats that are going to orbit around and really focus in on the current systems that are inside the Earth's aurora. We tend to think of the aurora as kind of one big oval that moves and breathes in and out as the storms are occurring, but there's incredible discrete structure inside that aurora. And so we're really going to be almost putting a microscope on those small current structures to really see how important they are in fueling the aurora, because the aurora, of course, is a big current system overhead and can cause all kinds of space weather impacts, including power grid failures. So lots of very important measurements that we're bringing in to further space weather.
Incredibly important. In fact, so I have to ask, will we be able to see the solar sail from Earth, maybe perhaps with a telescope?
No, it'll be too far away to actually see it. But they do have a student instrument that's part of their proposal, is to actually fly a camera that can look up as the solar sail is unraveling. So we're very, again, it's a really nice, it's a nice partnership. I love student collaboration, love giving opportunities for our early career students to really get hands-on experience of space and space hardware. It's such a critical element, but also to be able to take pictures of this solar sail up in the sky. Be wonderful.
All of these missions, as you've described, will provide knowledge and understanding important to our everyday lives here on Earth. Explain how we will all benefit.
So really, you benefit from just getting more knowledge about how our Earth is responding to what's coming from the solar wind. There's no way we can change what the sun is doing. It's a giant star. We know it's very variable, and we know it is continually, the atmosphere is continually expanding. We call that the corona. But we also see all of these transient events in the sun. And so we can't stop those transient events from happening, but what you can do is better forecast what's going to happen and then know how to respond. So how to protect yourself. You would listen to the weather before you were going on a trip, find out what kind of clothes you need to pack. If you need to take an umbrella, if you need to take extra sunscreen, you plan for those ahead of time. And so what we are doing with our space weather forecasting with a really great partnership with NOAA is better enabling the predictions and the forecasting of what's happening. And so what we're doing at NASA is we're really doing all of the science breakthroughs that are just better explaining these phenomena, and then we'll make transformational improvements in our predicting capability.
You're also planning for the next decade and beyond. In fact, can you give us a preview of Helio 2050?
Absolutely, yeah. So after the sort of breathtaking performance I think that we've done in 2020, we've had a great year with all of these new missions. We've talked about some of the other ones on previous visits I've had with you of, launching Solar Orbiter, getting the first light images, Parker Solar Probe blazing a trail through the sun's corona. We picked 5 missions for further study to go onto our medium class, and then all these new missions that I just talked about. So we've had an incredible year to date, and we're now looking forward to what do we want to do kind of in the next decade. And so we work with the National Academy of Sciences, and they give us a decadal survey. So once every 10 years, they look at kind of the state of the field and then give you almost a roadmap, if you like, of what kind of things you should be doing for the next decade. And so the last time they did that for us was 2013. And so we are closing in rapidly on the 2023, which is the end of our current decade. And so we are starting in earnest now preparation for that next decadal survey. And so we have a workshop, a community workshop that's called Helio 2050, as you said. That is May 3rd through 5th. It is all virtual, but we are really encouraging full participation from anyone with an interest in heliophysics, particularly as it's virtual. It's kind of easy to join. You don't even have to travel. Looking very much to our early career people, when I talk to them, I say, the next decadal survey, that's probably for me, but the one after that is yours. And so you need to be part of the community that's really dictating what the big science questions and what the really interesting things are that we want to find out about our kind of heliosphere system. So all the way from the sun, all the way to the edge of the heliosphere, everything in between. What are those really big questions? So, you want to have questions that maybe it's going to take you many decades to answer. If you think of Parker Solar Probe, that science was first, those questions were first sort of put into writing, if you like, in 1958. And so sometimes these things take a long time. If they're really, really great science goals, they can take a long time. And so then we break it up into what kind of technology improvements do you need to make along the way until you can actually fly these missions. So I really encourage anyone that's interested in the future of heliophysics and the future direction of heliophysics to sign in and join us for Helio 2050.
Dr. Nicola Fox, Heliophysics Division Director for the Science Mission Directorate at NASA. If somebody wants to connect with you, Nikki, maybe they want to find out more about all of these new missions, how can they do that?
So certainly nasa.gov has all the latest news for anything NASA. You can follow us on Twitter at NASA Sun, on Facebook at NASA Sun Science, and you can also follow me on Twitter at SolarGirl2018.
Sounds good, Solar Girl. And find more of my interviews right here on YouTube, iTunes, and Spotify, or at tonyahall.net. Thanks for watching.